Okay, story problems. Now let's read the first example, and these are the examples. It says if an eagle travels downward 600 feet over 5 seconds, calculate the average rate of change in the eagle's elevation. So you want to find the feet per second. Okay, so the feet per second, that's simply finding how many feet the eagle can travel in 1 second. Okay, we know he can do 600 feet over 5 seconds. How many can he do in 1 second? Well, to figure that out, it's just a division problem. Okay, take your feet, 600 feet, and divide it by how many seconds? 5 seconds. 600 divided by 5 is 120, so 120 feet per second is the answer. Okay, example 2. A bank account has $500. The person with the account spends $200, puts in $20, spends $400, puts in $250. Calculate the balance of the account after the last transaction. Money equals. Again, it's a simple kind of problem. You start with 500, then you spend 200, so when you spend, you'd subtract. Then when you put in money, you add. Then when you spend, you subtract. Then you put in money, you add. Okay? I find what the answer to that is, and that's going to be how much money this guy has in his account. So 500 plus 500 minus 200 plus 20 minus 400 plus 250. $170. Now you notice in those problems, in these next two problems, this example and this this next problem, I've got words that I put in bold letters, feet and seconds. These two I have no units in bold, okay? So when you don't have units in bold, that means you just need to solve the problem using your sense, okay? But in this next one, I'm going to flip the paper over. It says a skydiver jumps from a height of 3,200 feet. Notice I put feet in bold. He travels downward at a rate of 160 feet per second. You notice I put seconds in bold. Find the skydiver's height after 5 seconds. Feet equals. Now, when I give you those units in the bold, there's a certain way I want this done, okay? I mean, these first two are pretty cut dry. But I want you to use algebra then to solve the problem. You're like, well, how do you do that? Well, we did it in class. You're going to make a box. When I have these units in bold, I want to see the box, feet, and seconds. One of those is going to be, the time unit is my x. So x is feet, x is seconds, y is feet. X is always the time. Then I write per, P-E-R. Put the time unit below per second and then feet above. So what's the feet per second? Feet per second is 160. So since it's every second, it's 160 times x. Then after that's been identified, I had you make an XY table. You put the time unit here and feet here. And we always go 0, 1, 2. Now, before the 160 feet per second, how many feet did you have? You were at 3,200, okay? Then he's going downward, so I'm going to start minusing 160, okay? So after 1 second, he'd minus 160. $3,040. Then I'm minus 160 again. 2,880. Now this goes on. Okay, 0, 1, 2 is all you got to put. And since you were minusing 160, you want to jump back over here and make that a negative. Okay. Then I make another box with a line graph. Okay. Negative 160 times x is the rate of change. That goes here. Plus, how many feet did you have to begin with? You had 3,200 equals y. Okay. And now you're going to write the equation. Okay. So we have 3,200 plus negative 160 times x equals y. Now we're going to solve the problem. Put 5 seconds on your table. You need to put 5 in for x. Okay. So 3,200 plus negative 160 times 5 equals y. So I'm solving for y. Y is by itself, so I just plug in the expression over here on a calculator. So 3,200 plus negative 160 times 5, 2,400. So line up your equals, you have y, and this expression is 2,400. So that's how I want you to do it when I have 2 units in bold. I want the 3 boxes and then the table on the outside. Okay, next one. I did not put any units in bold, so you can solve it however you see fit. An object drops 600 feet in 4 seconds. Find the rate of change. We're finding the feet per second. Remember, feet per second is how far it travels in 1 second. Okay, that's easy to find. You simply just divide. Okay, take the quantity of feet, 600, divided by the quantity of seconds, 4, and that's 150. So if it goes 600 feet in 4 seconds, it goes 150 feet per 1 second. 1 second. Okay, now I'm going to flip over to the back here. Okay. Because now I give you bold units again. I'm going to remember bold units for now. When I give you 2 units in bold, that means I want the problem solved using variables. Okay. Just make 3 boxes right away when you see units highlighted in bold. A temperature in the evening currently sits at 68 degrees. Each hour the temperature drops at a constant rate of 4 degrees per hour. Calculate the temperature after 5 hours. Degrees equals. That's your answer to the problem. Okay, so the 2 units, we have degrees and hours. The time unit, hours, is always the x, and this is y. Then per, degrees per hour. Okay, the degrees per hour is 4. 4 times x. So I make my table. XY. X is hours. Y is degrees. Since I know my degrees per hour, I go 0, 1, 2. And before the 4 degrees per hour, we had 68 degrees. Now, I got to decide if that's negative or positive. I'm going to add or minus. Okay. Well, it's dropping, so it's going to be minus 4. Okay, negative 4. So I'm going to add negative 4 or minus 4, and then it's 64. Then I drop 4 the next hour. That's 60, and it goes on. So now I make my line, and negative 4 dot x goes here. Negative 4 times the number of hours. Now you started at 68. Okay. Equals y. Okay, so write out the equation. You got 68 degrees, and we're adding negative 4 times x, the number of hours, equals y. Okay, so we got 5 hours. I put 5 there, and that means I put 5 for x. Okay, so we have 68 plus negative 4 times 5 equals y. Okay, so y is by itself, so you just plug that into your calculator. You would multiply first, that would be negative 20. 68 plus negative 20, it's same as 68 minus 20, that's 48. 48 degrees. All right, number numbers on the back side, numbers 1 and 2, you just need to solve the problem, okay? Number 3, I want you to organize those 3 boxes with the variables, okay?